Kia ora. So today I'm starting a set of videos on 2.9 statistical inference. I will be talking over PowerPoints that we have made to use in our school. So come for the ride, but make sure that you are checking in with your teacher or making sure that you do what you have been asked to do at your school if it's different from us. So today we're looking at the problem, which is the first step. So we're given a whole lot of data, just like last year in the 1.10, if you did that particular standard, and we're being expected to again compare two categories to see what's going on back in the population. Now, the very big part of this one is that instead of the middle 50% as we compared in multivariate, we're looking at the medians. So the medians are the important part, and we'll be comparing the medians as our guide as to whether our statistical sample represents the population. So that's the first step that's different. We're going to look at the data set from NZ, thanks to Jake, of money spent at the formal. We've decided to just state that this stuff comes from Tail College. So this particular slide just explains what another sort of reason for setting up a statistical question. So a biscuit factory has expanded to a new site. The old site and the new site are both using the same recipe to make what should be the same cookies. Each cookie is expected to weigh 12 grams, and the company knows that there will be some variation. The question you want to ask is the new factory producing chocolate cookies that are bigger or heavier or whatever than the old factory? So that's what we're looking at, and we're not going to actually eat all the cookies or weigh every single cookie. We're going to take a sample of them. So when writing the question, slightly different from last year, this is the question that we would write. So we need the medians of the numerical value, not just the numerical value. We must state the word median. We've got two categories. We need to predict a direction. We've got to mention the population and state the year. So in this particular one, I've got for all Year 12 Tawa College students that attended the formal in 2018 is the median amount of money spent at the formal in New Zealand dollars by females greater than the median amount of money spent at the formal by males. So everything that you could possibly think of is in that question. So if we follow this template for all our questions, we should be good. For all, whatever your population is, and that will be mentioned in your write-up when you're given your topic. In years, that should also be provided to you. Is the median numerical value, so whatever you decided to compare, height, weight, cost, whatever it is, of categorical value variable 1, so males, females, old, young, white, black, green, orange, whatever the two things you are comparing, that's the first one. In units, whatever the units are, greater or less than, taller or smaller, or whatever those particular comparison words are, then the median of the numerical value for the second categorical group. So if you follow that template, you should be right. Some questions are bad. There has to be a believable reason to expect a difference. It's no point making a question that is either absolutely obvious or doesn't make sense to actually ask. So, for instance, this particular question, for all Auckland red-billed gulls in 2017, is the median length of red-billed gulls in winter smaller than the median length of red-billed gulls in summer? Why would you compare summer to winter? Do you think their bills get smaller in winter? So it's got nothing to do with the season, therefore you wouldn't expect there to be a difference. The gull might weigh less if food is harder to come by, so its weight might be something we can compare, but not its bill length. You should always do some background research, so look into the variables that you've been asked to compare, find out which one you want to do, have an interest in it, and find out if there's anything there that can tell you what you expect your answer to be. That's what a hypothesis is. So you might say, based on my background research, I think my sample will show that females spend a greater amount than males because their dresses cost a lot. Boys only have to hire suits, perhaps. Females have to often go out and do their makeup. So do males sometimes too. But, you're just talking about things that are a generalised pattern. We can always find exceptions to everything. So we need a purpose for doing it. This is usually just one particular sentence. So perhaps the school is interested in finding out how much students spend, and they want to look at whether they should make tickets less for females because they spend more money. It's unlikely to happen, but whatever the purpose is, you try and find some general group that would be interested in knowing your outcome. And you always mention your data source too, so usually it comes from a particular place. Although we put it into NZ Grapher, it's not come from NZ Grapher. And so we would always say the data source is people who attended the formal at Tail College in 2018. All right. Sometimes the purpose of an investigation is clear. Other times we might need to look into it. So with the cookies data, there is a commercial interest in checking that the new factory is doing as good a job as the old factory. Your data source, again, not NZ Grapher. Your data is in NZ Grapher. It doesn't come from NZ Grapher. So the cookies data, for instance, came from Cookie Factory's production run in March 2018. All right, I've just stuck another one up here at the end. So if you're in class or at home and you want to do this one, the data and the description are in NZ Grapher. So this is marathon data from New Zealand marathons between 2005 and 2007. And you've only got 4 groups here. In your particular one, you probably will have more things that you can pick between. But in this one, you've got the minutes they take to complete the marathon, male versus female, younger and older, and the person's average stride length over the marathon in centimetres. So 2 numerical ones and 2 categorical ones. Okay, give it a go.